What's up, people? How's it going? Welcome to my channel CPU. In this video, we'll be discussing about a very interesting problem, which is sum of XORs. So in this problem, we'll be given a value of x and then an array of numbers, and we want to find out the sum of the XOR of this particular x with all the elements of the array. Now, what is the motive for this problem? Say, we want to calculate the sum of XOR of all the pairs of the numbers in the array. In the naive approach, we'll be running two loops to find out all the pairs, and then for each pair, we'll be computing the XOR. So it will be having a complexity of n square, right? And then the n is given as 10 power 5, which means that we cannot adopt a n square solution over here because it will be giving us a TLE. So the expected time complexity is n log n, which means that n is for looping over all the elements, and we had to somehow compute the XOR of all the elements in logarithmic time. So that's the motive for this problem. So how to compute the sum of XORs in logarithmic time? Let's take a small example. Say the value of x is 5, and then we are given some array as 3, 6, 7, and 9. Right? So in the naive approach, we'll be just looping over all the elements from 3 till 9, and we'll be taking out the XOR with 5, and then we'll be adding that value to the sum, right? So this is a naive approach. Now how to solve this problem in logarithmic time? So as a first step, we'll be pre-calculating the count of bits in all the numbers. So what do I mean by that? So we can notice that all these numbers are integers, right? So they can be represented in 32 bits. So I'll be creating an array which has 32 bits in it. I'll be calculating the frequency of the bits for all the numbers. So what is the binary representation of 3? So it's nothing but it's 0, 0, 1, 1, right? So the first bit is occurring for one number of times. So let me just increment the first bit by 1. And the second bit is occurring for 1. So let me just populate this element by 1. Now let's go to the second element, which is 6. So the binary representation of 6 will be 0, 1, 1, 0. Now we can see that the first bit is occurring for 0 number of times. The second bit is occurring for 1 number of times. So let me just add 1 to it, right? And the third bit is occurring for 1 number of times. So let me just add 1 to the third bit. The next element is 7. So 7 in binary will be 0, 1, 1, 1. So the first 3 bits are occurring for 1 number of times each. So plus 1, incrementing it by 1, and plus by 1. Now let's move on to the next number, which is 9. So 9 in binary will be 1, 0, 0, 1. So the first bit is occurring for 1 number of times. The second bit is occurring for 0 number of times. The third bit for 0 number of times. And the fourth bit is occurring for 1 number of times. Right? So this is the frequency of all the bits for all the numbers. So after taking out the sum of all the elements, I'll be getting an array which will look something similar to this. So here we can notice that the first bit is occurring for 3 number of times. There is 1, 2, and 3. The second bit is occurring for 3 number of times. So 1, 2, and 3. The third bit is occurring for 2 number of times. And then the fourth bit is occurring for 1 number of time. Right? Now, how can we use this information to solve this problem? So ultimately, we want to calculate the sum of XOR. Now let's look at the binary representation of the value of x. So x is 5. So what is the binary representation of 5? So 5 can be written as 1, 0, 1. Now, what are the properties of XORs? So whenever we take the XOR of similar elements, then it will be leaving us a value of 0. And whenever we take the XOR of 1 and 0, we'll be having a value of 1, right? So with similar elements, the XOR will be 0. And with dissimilar elements, the XOR will be 1. Now the first bit is set, right? So just look at the first bit in this array. So there are 3 numbers among these 4 numbers which have their first bit as set. So if I take XOR of this particular bit with these numbers, then this will be becoming 0, this bit will be becoming 1, this bit will become 0, and this will become 0. So out of 4 values, 3 of the bits will be becoming 0, and only 1 bit will become 1, right? Among 4 numbers, there are 3 numbers which have the first bit as set, right? Now those numbers will be becoming 0, and then the number which was 0 initially will be becoming 1. Now, what is the place value of this particular bit? So, as this is the first bit, hence it will be having a place value of 2 power 0. So, if I take the XOR of this particular bit, that is the first bit, and then these numbers, that is the first bit of these numbers, then I'll be getting a value such that only one bit will be set and all the rest of the bits will be 0. Right? Only this bit will be set. So, we'll be adding this value to the answer. Now, let's move on to the next bit. So, the second bit in 5 is 0. Right? Now, there are 3 elements which have their second bit as set. So, we have 3 numbers which have their second bit as set. So, if we take the XOR of this particular value with 0, then it will be becoming 1. There will be 3 numbers which will be becoming 1 in the second bit. Right? So, we'll be adding 3 multiplied by the place value, and place value is 2. Right? So 3 is the number of elements which will be having the bit as set after taking the XOR, and then 2 to the power of 1 is the place value of that particular bit. Now, how are we deciding whether it's the total count minus this value or just the count? So we just need to look into the binary representation of 5. So if the binary representation of 5 is having 1, then all the elements which were 1 initially will be turned to 0, and all the elements which were 0 initially will be turned to 1. So it will be total number of elements minus this frequency. So for each and every bit, if the bit is set in the value of x, then we'll be adding total minus the frequency of this particular bit in this frequency array, and then we'll be multiplying it by the place value, which is 2 power bit. Right? Now let's quickly move on to the third bit. Now the third bit in 5 is set, and there are 2 numbers among these 4 numbers which have the second bit as third bit as set. So 2 numbers will be becoming 0 and 2 numbers will be becoming 1. So as this is 1, out of 4 numbers, there are 2 numbers which were 1s, and then the place value is 2 power 2. Now let's move on to the fourth bit. So we can notice that there is no fourth bit, which means that the fourth bit is 0. Right? Now we can see that there is one bit which has the value as 1. So when we take the XOR, so there will be only one bit which will be having this particular bit as set. So it is 1 times the place value, which is 2 power 3. So this is exactly how we'll be arriving at the sum of XORs. We'll be going from 0 till 30 number of bits, and if this bit is set in the value of x, let's say 5 in this case, then in the case of 1, we'll be taking out the total minus the frequency of the bit, and then we'll be multiplying it by the place value. Otherwise, if it's not set, then we'll be adding the frequency of this bit multiplied by 2 to the power of bits. That is the place value. As all these numbers are integers, so they can be represented in 32 number of bits. And 32 is nothing but it's nearly equals to log of 10 power 9 to the base 2. That's why we say that this algorithm has logarithmic time. So for taking out the frequencies of all the elements, we'll be having a complexity of n log n. And if we have some queries, then it will be taking logarithmic time. Now, let's solve one similar problem. So in this problem, we have to calculate the sum of XORs of all the pairs of the numbers in the given array. Right? So we want to compute the XOR of all the pairs. So how can we solve this problem? So let's say one of these values is x, and then rest of the values are the given elements of the array. So this is something similar to what we discussed over here. Now let's take the frequency of all the bits in these 3 numbers and calculate the XOR with this particular element. Right? So in this we would have covered this sum of XORs of all the elements with respect to 5. Right? Now let's just move to one step. So let's just take out the frequency of the bits of the number 9 from these three numbers, so that we'll be left with an array which has the frequency of bits of only these two numbers. Now, with this value as x, calculate the sum of XORs. So what I'm trying to say is, we'll be maintaining a window, and in subsequent moves, we'll be just reducing the size of the window by 1. How to implement the solution for this problem? So at first, pre-compute the frequency of all the bits of all the numbers. So let me just create a vector which has size of 32, or it can be just 30, as 10 power 9 is nearly equals to 2 power 30. I'll be looping over all the elements, and I'll be taking out the frequency of all the bits. So how can I do that? So we'll be having 30 bits, right? Now, if this particular number, that is array of I, has the current bit as set, right? So if the current bit is set, then let me just name this as frequency so that it makes sense. So I'll be incrementing the frequency of the current bit, which is j, by 1. So if the current bit is set in the value of array of I, then I'll be incrementing the frequency of that particular bit, that is j, right? Now frequency is the vector which will be having the frequency of all the bits of all the elements. Now let's just loop over all the elements once again. Now we want the current element to be acting as the value of x, right? So what is the current element? The current element is array of 5. Now let's say the 5 act as the value of x in this example. Now I want to remove the frequency of bits of 5 from the total frequency, which will leave us with a new array that will be containing the frequency of the elements 9, 7 and 6 only. So notice that I'll be looping over all the bits now. I just need to remove the frequency of the current element, which is x, right? So if x contains, if x has the current bit as set, then I'll be removing this bit from the frequency vector. That is, I'll be decrementing the current bit, right? So we'll be left with a vector which will be having the frequency of the elements 9, 7 and 6, right? Now the new x will be 5, and then the new array elements will be 9, 7 and 6. Now we'll be just adopting the same strategy which we discussed over here, right? Let's loop over all the bit values, which is 0 till 30. If x has that particular value as set, then what should I be including into my answer? So if this bit is set, then I'll be including total minus the frequency of this bit multiplied by the place value. So what is the total number of elements that are left after considering the current element? I'll be left with n minus I minus 1. So let me just say I'm standing at the element 9. So if 9 is taken as the x value, then all the elements to the right hand side will be considered as the elements of the array. So as this position will be having an index of 1, so it will be like n minus 1 minus 1, which is n minus 2, right? That's the total count. So the answer will be total minus the frequency of this particular bit. So the bit value is j, and now this should be multiplied with 2 power j, right? So let me just declare the variable answer over here. And also, as this product can go beyond the range of integers, so let me just multiply this by 1 long. Now in the else case, the answer will be just frequency of bit multiplied by 2 power the bit value. So 1 long multiplied by frequency of j multiplied by 2 power j, right? So this is how we'll be solving this problem. So the outer loop is going for n number of times, and then the inner loops are going for 30 number of times, which is log of n. So the ultimate complexity will be big O of n log n. Now at last we'll be returning the answer, right? So let me just compile this. So we are getting the correct output. So let me try submitting this solution. So all the cases have been passed. So this is how we'll be solving this problem. I hope you understood this method of calculating the sum of XORs in logarithmic time. So if you have any further queries, do leave them in the comment section. And if you like this video, consider giving it a thumbs up and do share with all of your friends. Thank you.